Welcome to the world of circle geometry. Today, we will explore a fundamental relationship between angles that share the same arc. Understanding this connection is the key to solving complex geometric proofs and engineering designs. From architectural design to the way we position cameras in a stadium, circle geometry ensures that angles remain consistent. Let's dive into the core definitions to see how these angles are formed and measured. A central angle is formed when two radii meet at the center of the circle. The vertex is always the center point O. The measure of this central angle is exactly equal to the measure of its intercepted arc. In contrast, an inscribed angle has its vertex located on the circumference of the circle. While it subtends the same arc AB as our central angle, its position further back suggests a different measurement. Let's find the link. The fundamental theorem states that the central angle subtended by an arc is double the inscribed angle subtended by the same arc. If the inscribed angle is x, the central angle must be 2 times x. Notice that as long as the vertex P stays on the same arc, the inscribed angle remains constant. No matter where you move on that arc, the relationship to the central angle stays exactly the same. Consider a diameter. The central angle is a straight line of 180 degrees. Therefore, any inscribed angle that faces a diameter must be exactly half of that, which is 90 degrees. This creates a right-angled triangle. Let's apply the rule. If we are given an inscribed angle of 40 degrees, what is the central angle? Since the central angle is double, we simply multiply 40 by 2 to get 80 degrees. Now, let's work backward. If the central angle is 110 degrees, the inscribed angle must be half of that. Dividing 110 by 2 gives us an inscribed angle of 55 degrees. Always check if they share the same arc. In more complex diagrams, you might see multiple inscribed angles. If they all open up to the same arc, they are all equal to each other and all equal to half of the central angle. Here, both y and z are 75 degrees. A common mistake is applying this rule to angles that don't share the same arc. Always trace the lines back to the circumference. If the end points of the angles don't match on the arc, the relationship doesn't apply. We can also use algebra. If the inscribed angle is 50 and the central angle is for x plus 10, we set up the equation for x plus 10 equals 100. Solving for x, we find the value is 22.5. To summarize, the central angle is always the larger one, located at the center. The inscribed angle is the smaller one, located on the edge. They are related by a factor of 2, provided they share the same arc. Remember these 3 things: check the vertex, ensure the arc is shared, and look for diameters that create 90-degree inscribed angles. These rules are the foundation of circle geometry. Test your knowledge. If the central angle is 130 degrees, what is the measure of the inscribed angle A? Take a moment to calculate the answer using the rules we just learned. The answer is 65 degrees. Since the inscribed angle is half of the central angle, dividing 130 by 2 gives us the correct result. Well done if you got it right. Geometry is all around us, from the smallest atoms to the largest orbits. By mastering these angle relationships, you've taken a big step in understanding the logic of our physical world. Generated by Vision Solve AI.